Compared to Earth, the Moon appears to be perfectly dry and airless, but in fact, it possesses an extremely sparse atmosphere, barely thicker than a vacuum. From late 2013 to early 2014, a NASA mission called LADEE explored the lunar atmosphere and dust environment. Now, LADEE's observations have led to a new discovery about the Moon's water.
During the initial exploration of the Moon and the analysis of all the return samples from the Apollo and the lunar missions, we thought the surface of the Moon was dry. But more recent missions, like Lunar Prospector, LCROSS, and Lunar Reconnaissance Orbiter, have not only shown that the surface of the Moon has a global hydration, but there are actually high concentration of ice water in the permanently shadow regions of the lunar poles.
In the decades following the Apollo program, a series of robotic explorers revealed tantalizing hints of water on the Moon, challenging the conclusion that the Moon was dry. The first definitive discovery of water was made in 2008 by the Indian mission Chandrayaan-1, which detected hydroxyl molecules spread across the lunar surface and concentrated at the poles. The following year, NASA's LCROSS mission deliberately impacted part of its launch vehicle into the southern crater Cabeus, ejecting a plume that contained water ice. These discoveries showed that the Moon harbors water and that the highest concentrations occur within darkened craters at the poles. But questions remained about the abundance of water at the Moon's mid-latitudes. Now, data from LADEE are beginning to provide answers.
What we discovered is that the surface releases its water when the Moon is bombarded by micrometeoroids. This is especially noticeable during meteor showers. What we also found is that the surface that's releasing the water is being protected by a layer of few centimeters of dry soil that can only be breached by large micrometeoroids. When a micrometeoroids impact the surface of the Moon, most of the material in the crater is vaporized. There is also a shock wave that propagates outward. That shock wave carries enough energy to release the water that's coating the grains of the soil. Most of that water will get released into space, and that's the signature that LADEE detects with its instrument from its orbit.
LADEE observed water being released from within the Moon, but the micrometeoroids impacting the Moon's surface have a more exotic origin: comets. When Earth passes through the leftover debris trail of a comet, small particles of rock and dust burn up in our atmosphere, creating a meteor shower. On the Moon, these micrometeoroids impact the surface, releasing water at the same time that meteor showers are occurring on Earth.
By analyzing the data returned by the neutral mass spectrometer, we found that the intensity and the frequencies of the fluctuations of signals from the water to be perfectly correlated with known meteor streams. For example, we were able to detect a big spike of water during the Geminid meteor shower that occurred in December of 2013.
Knowing how much water is available at the Moon's mid-latitudes is important for future exploration. LADEE's observations show that beneath 3 inches of dry lunar soil is a wet layer 10 feet deep. But on the Moon, wet is a relative term.
The concentration of water in the wet layer is about 200 to 500 parts per million per weight. So to fill an 8-ounce bottle with lunar water, you would need to squeeze water out of about 1,000 to 2,000 pounds of lunar soil. So while the wet surface is wet, it's drier than you think.
The search for water on the Moon spans 5 decades and is of great interest to future exploration. Thanks to LADEE, we now know that trace amounts of water are widely distributed across the lunar surface.